Introduction to the Logistic Growth Model. Hi. In this explanation, we will explore the Logistic Growth Model, a widely used mathematical model that describes how populations grow in a limited environment. Unlike exponential growth, where populations increase without any restrictions, the logistic model incorporates the concept of a carrying capacity, the maximum population size an environment can sustain over time. To make this concept more interactive and engaging, we will use a simulation in Altair Compose, which visually demonstrates how populations evolve under the constraints of growth rates and environmental limits. By observing the simulation, you'll gain a clear understanding of how the logistic growth curve transitions from rapid initial growth to stabilization as it approaches the carrying capacity. Through this model, we aim to explain the factors influencing population dynamics, the mathematical foundation of the logistic growth equation, how the carrying capacity and growth rate shape the population's behavior over time. Let's dive into the details and explore the simulation together. The script models population growth using the logistic growth equation, which describes how a population grows over time while considering limitations like resources and habitat. First, let's define the parameters. The initial population, labeled as P0, starts at 100 individuals. The growth rate, represented as R, is 0.3, meaning the population grows by 30% of its size per unit time when it is small. The carrying capacity, labeled as K, is 1000. This is the maximum population size that the environment can sustain due to limited resources. The time range is defined from 0 to 50 units, divided into 500 evenly spaced points. Next, the script uses the logistic growth formula. P of t equals k, divided by 1 plus the fraction of k minus p0 over p0, multiplied by e to the power of negative r times t. Here, p of t is the population size at any given time. K is the carrying capacity. P0 is the initial population size. R is the growth rate. T is time, and E is the base of natural logarithms. This equation describes how the population grows quickly at first but slows as it approaches the carrying capacity. Finally, the population is plotted over time. The x-axis represents time, while the y-axis represents the population. The title of the graph is Logistic Population Growth Model. A blue line shows how the population starts small, grows rapidly, and then slows down, eventually stabilizing at 1,000 individuals. This model demonstrates how populations grow in real-world environments where resources are limited, capturing both the early rapid growth and the eventual stabilization.